press fitting, and that's straightforward. Basically, you're just pressing two parts together. But as a rule of thumb, basically, if you have any metal, you just want to make sure that your tolerance is 5/10 on it, so 0.0005 of an inch, and that's a good rule of thumb. If you have that tolerance on each one of them, you'll have maybe like 2/10 interference. You'll be okay. But if you have like a plastic or whatnot, that's going to be greater. But as a good rule of thumb, 5/10 is good. You can go deeper into the calculations and see exactly what's happening. But if you're using that, there's no going wrong. Everything will pretty much fit. So pinning is another way of attaching gears and components to shafts. You have to keep it in place first while you're drilling, and then a roll pin is suggested. Instead of a standard shear pin, it's always better. Next slide. Some of the issues we see with a lot of precision applications is that even though the set screw is a very common attachment method, when it comes to precision application, when you tighten the set screw, it raises the shaft surface. And if you're servicing or do something wrong and you got to take this apart, it is going to be very hard to take apart, and it might also damage the shaft itself. So that's one of the drawbacks of set screws, but it is a viable attachment method. But you don't really want to use that for precision parts that you intend on servicing. Now, another type is the compression type of attachment. We're going to talk the fair lock and the shaft lock. So it's a clamp type. Next slide. So another attachment method is the keyway. One of the drawbacks of a keyway is that it requires precision machining tolerances for both the shaft and the mechanical component. And then also it requires axial fixing, such as a set screw or retaining ring, as you can see in the diagram there, to keep it going any direction axially. Also, it can be complicated to service depending on your situation. But again, just wanted to reiterate, the compression type is the best in most scenarios, especially when you have to service parts. So next slide. So just general size and weight, material, field service, these are all considerations to take into account when attaching a gear to a shaft or any other component. So one piece, again, design is best to prevent from parts falling out. When regards to a clamp, the fair lock is the best one that we find, and again, it's a one-piece construction. So the fair lock is the most compact, self-contained one-piece design. It has the most accurate axial and concentric movement, and it has the maximum clamp torque versus size compared to our competitors. Next slide. Here's an example of the fair lock being incorporated into a bevel gear set. Basically, you can adjust and readjust the clamp as many times as you need to find that pitch apex to back. Once you find the pitch apex to back, you tighten the screws on this, and this will never go away. We provide charts for torque, transmission, and different bore sizes. So we have all the information, all the data that you need to know how this part will perform. The only thing is that you have to make sure you have very accurate clearances. You don't want anything more than 8/10 of a clearance between the shaft and the bore. If you do, you'll just decrease the best situation for torque, but you'll still be able to transmit. You just have to make sure you test how much you're transmitting. Next slide. Another option is the shaft lock sleeve. It's not as accurate, but it does allow for a good amount of torque transmission.